Hi everyone, I wanted to run through the next lab, which is Qualitative Analysis of Cations. Now before I do that, I wanted to mention a few things about your last lab, which was separation of mixtures. Some of you did really well. You got like 100% because you correctly calculated the percentages of the three components in the mixture. Okay. Many of you got a very low score because you incorrectly calculated the percentages. Okay. And it came down to the math. Okay. So if you didn't do the math right, you got a pretty low score. Okay. Now, fundamentally, if you think about it, if I got a 10-gram mixture and 5 grams is one thing and 5 grams is the other, that's 50%. Many people were quoting a fraction instead of a percent, right? And that was way off, all right? So look back on that. If the percents don't add up to 100, it's not right, okay? Try the math again, all right? Another quick thing, okay, was full answers, okay? So yeah, the answer is 67%, but you don't write 67%, you show the math, okay? So many of you miss points on the questions at the end because you have to show work every time in a chemistry question, okay? Don't just write the answer. Don't. Write the work and then the answer. Most points, as you've probably already figured out watching this after you've got your quiz grade back, most points are full work, okay? Another thing, real quick. So, say I had that one, right? 5 grams of sand over 10 grams of mixture. And most people, not most people, a lot of people did this, right? And they said 0.5, which is right as a fraction, right? Then you multiply it by 100 for a percent. So if I write that, is that right? No, it's not right. Think of the equals like a balance, right? So what you said is that divided by that is 0.5. 0.5 does not equal 0.5 times 100, which would be 50. 0.5 does not equal 50, okay? You can't do work along the way. You can't kind of press equals along the way. If you look back to your conversion factor video, you'll see that's super important, okay? All right, so you don't press equals along the way, okay? It doesn't make sense mathematically to do that. And, you know, if you did that, you didn't get any points, right? So it's very simple math. You have to have the math logic down, okay? All right, sermon over. Now, hopefully you got this one sitting in front of you, okay? Analysis of the group 2 ions. Now you might think, oh, that's group 2 magnesium group. No, it's not, okay? The group 2 ions are silver, Mercury, which is a bizarre 2 metal atoms stuck together, right, ion, and lead. They're special because they all make solids with chloride, okay? So everything, and we'll get to a lecture later where this, you know, we talk about it formally, and you don't need that lecture right now to do this. This is actually a good introduction to that topic. All right. So it turns out that everything else in nature that's ionic and stuck to a chloride, sodium chloride we know, dissolves in water, right? Everything, every metal from the periodic table with chloride dissolves, apart from these three, and they're called the quote-unquote chloride group. We're going to do a qualitative analysis. Qualitative means yes or no, okay? So we work out a scheme in which we kind of separate these off one by one from a mixture and say yes or no if they're there, okay? And to do that, we'll, unfortunately virtually in your case, right, but in lab, I just basically give you a bottle which I know has all three in, and we develop a flow chart to separate them off and test yes or no for their presence, okay? And what I want to do is go through that nice and slow with you right now. All right, now, good news, bad news, okay? This is our first, if you like, true chemistry experiment. It may seem more challenging than the previous, right? If you think about it, separation of a mixture, simple math, right? Density, simple math, yeah. So those are really high school experiments, right? This is your first, if you like, college chemistry experiment. So it's a little bit harder. My suggestion, as always, is try this early, right? Look at it, and if you've got questions, talk to me in the office hour on Thursday. Okay, kind of disappointed. I've had 4 people in the first office hour week 1, 0 in week 2, and 1 in week 3. Okay. So hey, you know, try and organize. Look at stuff before the office hour if possible, then come to the office hour if you've got a question. Okay. All right. Now, what I'm going to do, I of course, you know, should this be the actual semester, I actually have a pre-lab, which I'll go through with you, right? So I'll kind of reproduce my actual in-class pre-lab, right, for this experiment, okay? So, objective. The objective is to construct a flowchart for the ID of chloride compounds. Now the good news is you don't have to reinvent the wheel, okay, because in your packet it's already there, okay. What we're doing is we're just confirming how to use this flowchart, right, and that's what I'm going to do with you right now, okay. And then when you have an unknown, if lead, for example, is not in your unknown, you won't get a positive result here. It's kind of, that's how a flowchart works, okay. All right, so we've got to have the whole map first, okay, and then when you do your unknown, you may have 1, 2, or all 3 of the unknowns, and you'll have positive or negative tests for each one. Okay, so that's the overview, right? All right, so first things first, we'll construct a flowchart for the ID of the chloride compounds, and then use the chart to find which ions, and it can be 1, 2, or all 3 of them, any 1, any 2, or all 3 in an unknown. And if you've checked, and I should say this right now, if you checked online, this is not through Pivot, right? So it's one of those labs we don't use Pivot. It's actually done via a separate site. So go to the group Chem 101 site. And my advice is not to click on the links to a website. Just follow the instructions and there'll be like a written link, okay? So it takes a little bit of time to find it. It's actually right there in the instructions, okay? So once you find the, I think it says virtual lab or something, click that and it takes you to the place, okay? So let's get into it. Now, background. So you make sure you understand this background. If you don't understand the background, none of it makes sense, right? Okay, so background. Ag plus, as we mentioned, Pb2 plus, and Hg2 plus aqueous react with chloride to make sure these are all aqueous, right? So when dissolved, these ions, right, to make solids. We call those precipitates, right? Okay, so if I was to do like a generic balanced equation, right? So X, aqueous, and we'll go N plus, right? So if that was silver, that would be plus. This is a generic. This is any one of these, right? If it was lead, it would be 2 up there, right? If it was mercury, well, a bit weirder, right? But you get the idea. So that's a generic, right? So that's any one of these, right? Plus NCl minus. So I'm having a dissolved ion, I'm adding dissolved chloride, and it turns into the solid, okay? So 2 aqueous things bump together and stick and form a solid, right? So when you do this as an experiment, you have 2 clear colorless liquids, you'll mix them together and they form a white solid, okay? And you separate the solid from the liquid by techniques we'll talk about, right? Okay, so that's your generic, right? Okay. If you had a mixture with all these 3 in there, this would just basically make a white solid with all these solids inside, okay? So it doesn't really help you to do this first step. Yes, it separates the ones that are solid away from the ones that are aqueous, fair enough, right? But it doesn't individually separate and identify them, okay? So that's a problem. Problem. How do you separate and ID the individual precipitates? Now, before we get any further, let's look at the flowchart. All right. Now, should this have been lab, okay, we'd start here. I'd give you literally a brown bottle, right, with these ions inside it, right, dissolved, all right? So later on we'll find out that nitrates always dissolve, so silver 1 nitrate, lead 2 nitrate, and mercury 1 nitrate would be dissolved and be aqueous, right? So these aqueous ions would be in solution, okay? Then we add HCl, so, you know, if I kind of write on my sheet here just to show you guys. So you have these ions in solution, yeah, Okay, so they're swimming around. Then you add HCl, and that's really a source of Cl minus, right? So if you add Cl minus, you get this generic reaction. They all form their respective solid, right? So hey, the Ag hooks up with the Cl to make AgCl solid, and R stands for residue, right? So that's a solid, right? So we can write there solid, right? Lead chloride, lead 2 chloride, and mercury chloride. Okay, so we make these three solids. So we'll have a liquid sitting above and a solid sitting below. Interesting. All right, so we've made the three precipitates, right? Okay, through our simple first generic reaction. All right. So the problem, how do you then, for that little pellet of solid sitting in the bottom, how do you separate them off individually? You have to do what's called a secondary tests. Okay, it's like a bunch of sheep, right? So you separate off one sheep from the herd at a time. Okay, and that's what the flowchart is. So a flowchart allows you to individually separate lead, mercury, and silver individually, and then you confirm they're there with a test. Okay, all right. So let's look at those individual tests and keep flipping back to the sheet, right? Okay, so first things first, the easiest one is lead chloride. Lead 2 chloride, we'll call it. All right, because it's Pb plus 2. All right. Now, if you look at our sheet here, okay, we have an interesting fork in the road. What you actually do, and hopefully this is shown in the video, right? Okay, or online, right? How do you separate a solid from a liquid? Well, if you've ever been to the fairground and in one of those machines that spins you around really fast, you've personally been centrifuged, okay? So bottom line is, you've probably seen these things. You put a test tube in a machine that spins around real fast, okay? If I have time, I'll link a video to that, right? Okay, the solid will sit in the bottom and the liquid will stay on top, all right? And all you do is you pour off the liquid, wash the solid somehow, okay? And then you have solution and solid, okay? So residue 2 is what's left behind. Solution 2 is what's on top, okay? So it's centrifuge, spin it around, and decant. Now, turns out that lead is soluble in warm water, okay? So if I just put a little bit of water in there and heat it up, the lead will go back into solution as 2 plus ions, right? So let's look at that real quick, right? So PbCl2 solid, that's sitting in that pellet of all three, right? And you heat it up, change, right? Boil, if you like. Turns into Pb2 plus aqueous plus 2Cl2, 2Cl minus rather, aqueous, right? So it's gone from solid to aqueous. Oh, let me show you that, sorry. So the solid that's sitting in that pellet has turned back into a solution. Okay, so that's how we have a fork in the road. Every time we have a fork in the road, we centrifuge and decant. We take the liquid off, which will have dissolved iron, one of them, right? So we've taken off Pb, right, from the solid because it dissolves when it's hot, right? And the others remain in that solid, right? So we leave them in there. All right, so it kind of looks like this, yeah? Now, fair enough, right? So you can't really tell by looking. I mean, how do you know that's actually in your solution, right, after you heat it up? Well, you've got to do a confirmation test, right? And that's where this arm of this sheet comes. So you take that clear solution from up there, which you think has lead 2 plus in it, you add this stuff, okay, and it'll form a yellow solid, okay? So lead, when mixed with chromate, forms yellow lead chromate. It's the formation of a yellow solid, okay? So that's confirming it's there. So you pour it off, test it separate. If you see a yellow solid, lead's there for sure, okay? So you see how we're using a flow chart to separate off individual solvated or dissolved ions from the solid, and then once we separate them away, we test them to confirm they're there, okay? In your unknown, okay, if lead is not there, you won't get a yellow solid when you test the liquid. Got it? All right. So confirmation, this one, Pb2 plus aqueous plus Cr04 2 minus. This is all in the book. You can look at it. PbCr04 solid. That's a yellow solid. Okay, so that's your lead. That's your lead. And sequential separation and identification depends on solubility. Okay, so under certain conditions, certain ions will be soluble. For lead, it's not soluble. It dissolves when it's warm. Okay, next one, silver chloride. I'll call it silver 1 chloride. Okay, so if you think about it, so let's just recap. We've got our solution of ions, we've added HCl and formed a white solid that contains all three. We've taken that white solid away, added some water to it, heated it up. The lead dissolved back into solution, so we centrifuge and decanted again, so we spun it down so it separates solid from liquid, pour off the liquid, tested that liquid with chromate and it turned to yellow solid. Lead's there. Okay, fantastic. However, sitting in that pellet, if it's an unknown, it could be one or both, right? Okay, if there's nothing left, you only had lead as an unknown, that's nice, right? But if you do have a solid remaining, it may contain silver chloride and or mercury chloride, fair enough, right? How do we separate the mercury from the silver? Well, it turns out that silver is soluble in ammonia. So if I just add some ammonia solution to that mixture of things in the solid there, silver will dissolve and we can centrifuge and decant, get it out in the liquid, right? So silver chloride, so AgCl solid, which is in our remaining pellet, right? Which is residue 2, all right? Plus, don't worry about these equations too much, they're just to illustrate, right? Turns into AgNH3 twice plus aqueous plus Cl minus. Okay, so once again, the NH3 twice is in the liquid phase, right? So it's gone to the liquid. Oh, move that for you, sorry. So there's the solid in the pellet. Mix it with ammonia, it dissolves, all right? So if we go back to our chart, if we add ammonia, and every time we have a fork in the road here, it's centrifuge and decant, so centrifuge, decant, right? Centrifuge, decant. So spin it down, separate solid from the liquid, decant, pour the liquid off. There's your solution, which contains this guy, and the solid is left behind, okay? So we take our solution away. Is it there, yes or no? We can't tell because it's a clear colorless liquid, right? Throw some HNO3 in there and it will come back, okay? So confirmation, if I take that, what we call complex ion, plus Cl minus in the presence of acid. Again, don't worry too much about the details of the equations, it's just the means to an end. AgCl solid plus 2 NH4 plus aqueous, and there's your solid. Okay, so if you see the reappearance of a white solid, it's not labeled, it should be residue 3 maybe, right? Or something. All right, if you see the reappearance of a white solid, silver was there after adding ammonia. Okay, now the least soluble of all of them, as you can probably tell from the flow chart, is mercury, right? But mercury changes from one kind of solid to another kind of mixed solids, okay? So if I add ammonia to this solid, it turns into these two solids. So it stays solid. So if anything remains after adding ammonia, yeah, if you've got a solid left behind, mercury was present, but it's turned into these two different solids, okay? That one's black and that one's white, so it kind of looks speckled. It's kind of fun to do this experiment because you see kind of a speckly gray solid at the end. It changes color. So it's the least soluble, it's the hardest to see in terms of a positive confirmation test. These guys easy, just dissolve them and then bring them back. This guy, you see a color change, okay? And you can, I won't write the equation for that because it's in the packet, okay? But if you ever, are asked what happens with this solid when you add ammonia, it turns into these two solids, okay? That might be a question, okay? All right, so that is testing. So in the first part of let's just go over here now. Part 1, you essentially in part 1 are asked just to confirm the validity of the flow chart, okay? So you just confirm what happens in each of these steps doing a virtual experiment. Okay, so you do this part, you should see yellow solid. You do this part, you should see a white solid come back when you add ammonia to this. Here you see just this kind of grayish, specklish solid left behind, okay? So that's your map, that's your whole map, fair enough. Now, what you hand in is your unknown sheet, all right? So just like with the last experiment with the separation of a mixture, you have an unknown based on your birthday, so download the right one, right? Okay. Let's write it down. So you complete the chart for your unknown, right? Okay, and it's a blank chart, yeah. Okay, so it's a blank chart, and say you didn't have lead, right? Say you did the lead test and nothing formed as a solid. Well, you just scratch that out on your unknown. It's not there. All right, okay. But say yes, you got to the end here and that was there, and you got to the end here and that was there. Make sure you write on your answer key, answer unknown, I don't know what number, right? 101 equals, we found mercury and silver. Okay, so if the chart filled out all the way down this left side, you had mercury and silver. If you didn't get a positive test here, you had no lead. Fantastic. So that is your final answer. So make sure you write on the bottom of your sheet. So fill out this sheet only with the positive tests you see. You could have just one iron. If you just had lead, oh, that's a fantastic lucky day for you because it's the easiest of the unknowns, right? If you have all three, well, that's an unlucky day because it's kind of the most complex of all the unknowns and they're randomly assigned, so I can't tell you who got what, right? But anyway, based on how the experiments go with yes or no confirmation tests, you can tell me what's in there. So all you have to do, send me back this unknown sheet, your name, your unknown number, and then what's in it. Okay, and then what's in it. Okay, it's kind of redundant information, but I want you to write on there what's in there. I could figure it out here, but I want you to write it. Just confirm what's in there. Okay, so I'll make this due on Friday, the normal day. Okay, hopefully that makes sense. Again, discussion, office hour. If you've got any questions, try and get to this earlier than Thursday, right? Okay, because I'm available Thursday morning, okay? Doing it last minute is never a good idea. Okay, so stop there. I'll see you guys next time.